Dear students, so we are starting with our next topic, that is hydroelectric power plant. So this is the second topic in case of this introduction to energy sources and its conversions of subject systems in mechanical engineering. So in last lecture we have seen thermal power plant. Now in this lecture we are going to see hydroelectric power plant. So we'll see what is meant by this hydroelectric power plants. So hydroelectric power plant, uh, in which the generally potential energy is stored in a water, and this uh, potential energy which is stored in a dam is made to use of running of water turbine, and this water turbine again coupled to or connected to electrical generator. So we convert potential energy into electrical energy by means of this hydroelectric power plant. So in hydroelectric power plant, it is estimated that about 23% of total electric power generation in the world is comes from hydroelectric power plant or hydropower plant. So in India, we have in Tamil Nadu, the total generation of power from hydroelectric power plant is almost 1950 megawatt, and in all India level, it is 18,000 megawatt. So this amount of water is this amount of electricity generation or electricity is generated by using this hydroelectric power plant. Now this hydroelectric power plant is also called as hydropower. So it uses a water power to convert the power or to produce the power or electricity. So we'll see in the layout of this hydroelectric power plant. Generally, in hydroelectric power plant, there are different parts. So we'll see this first, what is meant by working, and then we will see the function and components of each part. So first, I will explain what is meant by the layout of this hydroelectric power plant. So if you see this layout, it consists of a water level which is in there, a dam is there, dam is constructed on a river, and the water level is there. Now we have this pipe which is generally called as penstock. It is a large diameter pipe from which the water is flowing through this pipe, so potential energy is converted into a kinetic energy. Then we have control valve, and there is turbine and power station is there. So where uh, this kinetic energy of water, generally it is called as a hydraulic energy, is converted into a mechanical energy, that is the rotational energy of the turbine. We have other parts like trap tube is there, surge tank is there. These are the parts are there. Now we will see how this hydroelectric power plant works. So if you see in hydroelectric power plant, the water from dam. So we have a water. So water from this dam is brought to this water turbine by a large diameter penstock pipe. So this is a penstock pipe which having a large diameter. The penstock pipe is generally made up of a steel, or it may be made up of a reinforced concrete. Okay, it is made up of either steel or it is made up of a concrete. Now, it is desirable to eliminate this sharp bend and all that. So, is to avoid the loss of head and special anchoring. So, for supporting this pipe, we does another part is called as anchors, which support this penstock pipe. So, anchor is a supporting structure which supports this penstock. So, to avoid these losses in pipe, Either it may be kinetic losses or losses in pipe. We avoid the bending of this pipe. So depending upon the load on turbine, the amount of water is automatically controlled by a valve. So by this valve, we can automatically control the amount of water needed based on the electricity generation, or we can say a load on turbine. So the amount of water is sudden, for example, in case the amount of water is suddenly reduced or stopped by a governor mechanism, the water coming down from high velocity will produce turbulence effect and resulting a water hammering effect. So, and because of this water hammering effect, the penstock may be damaged due to water hammering effect. So to prevent this water hammering effect, we have another part that is called as a surge tank is there. So to prevent this water hammering effect, the surge tank is provided. So from turbine, water is allowed to pass through a draft tube to the tail race. So the tail race is the water path which is leading to discharge of water from turbine to river or canal. So this is the general working principle behind this hydroelectric power plant. So we convert this potential energy. So water is having potential energy. Now because of this potential energy gets converted into kinetic energy. Then this kinetic energy is strike to the water turbine and which convert this kinetic energy into a shaft power, or it is also called as a mechanical energy. Now this turbine rotor is connected to generator which converts mechanical energy into electrical energy or electricity. So in this way, we convert the potential energy of water into kinetic energy, then kinetic energy of water into mechanical energy by means of hydraulic turbine, and from mechanical energy to electrical energy by means of a generator. So this is the working principle behind this uh, hydroelectric power plant. Now we'll see the different parts of this hydroelectric power plant. So the parts or component of this hydroelectric power plants are: the first part is forebay. This is the first part. Second part is your intake structure. This is the second part, intake structure. Third, penstock. Fourth, we have surge chamber, or it is also called as a surge tank. Fifth part, it is hydraulic turbine, or it is also called as a water turbine. Sixth, it is a powerhouse. Seventh, draft tube, and eighth part is tail race. So these are the major components, or we can say a major parts of this hydroelectric power plant. Now in hydroelectric power plant, we convert the power of hydro or water into an electricity, that is the electrical energy. So we have first part, it is the forebay. If you see, this is the actual forebay. Here, the actual forebay is given. So if you see, a forebay is a basin area of hydro power plant. This forebay is also called as a basin area where we can store water temporarily. Okay, we can store water temporarily in this area, so that area is known as forebay. Before it goes to the intake structure or intake chamber, and after that it will go to the penstock. So if you see this forebay, it is a basin area of hydroelectric power plant where we can store water temporarily before going to intake chamber, and after from that intake chamber we are passing this water to surge tank. So the storage of water in forebay, it is decided on the based on requirement of water demand in that area. So what will be the storage, how amount of water, how many amount of water is stored in that Forway, it is based on the requirement water demand in that area. And this is also used when load requirement or intake is less. So we can use this Forway when there is load requirement or intake is less. Load requirement means the electricity generation is less. Now we know that a reservoir, or generally reservoir, or it is also called as a dam. A reservoir are built on across the river to store the water. And water stored on upstream side of dam, it is carried by using a penstock to powerhouse. So in this case, a reservoir is itself acts as a Forway. So sometimes a small reservoir is there, so that reservoir also acts as a Forway, or we can say dam is also act as a Forway. So it may be directly there will be a dam which is built on river, or it is a temporary arrangement where we can use this water for electricity generation. So this is the first part of hydroelectric power plant, that is the Forway. So if you see in this, there is a head of water, there is a Forway, and from the Forway, the water is supplied to penstock, and then we have turbine and the generator and powerhouse. So all that there are tailrace and all that. So this is the first part, that is the Forway. Now we have second part, that is known as intake structure. So generally this intake structure, it is built on a dam. So intake structure, it is a structure which collects water from Forway, which collects water from Forway, or it may be a from dam. And this directs water it into a penstock. So what is the function of intake structure? The function of intake structure is to collect the water from Forway and direct it into a penstock. Now in intake structure, we have a trash rack is provided. There are different intake structure is also available in case of hydroelectric power plant. And the selection of this intake structure is depends upon various local conditions. The intake structures contain some important component. That component is known as track rack. Track rack. It is known as trash rack. So this trash rack, it plays a vital role or important role in this hydroelectric power plant, as this trash rack provides there at entrance of the penstock. It is generally it is at the entrance of the penstock, and the function of this trash rack is to trap the debris in the water. So it traps the debris in the water, and if this debris, water impurities or debris in the water, is goes along with this water flow into penstock, it will cause a severe damage to the wicket gate, to turbine nozzle, to runners of the turbine. So because of this water debris, there is other component of hydroelectric power plant, it gets damaged. So to avoid this, we use this trash rack in that intake structure. So generally these trash rack are made up of steel rods. So like this, these are the steel rods are there. This is intake structure. So there are number of steel rods are there. So these steel rods is arranged of 10 centimeter to 30 centimeter of gap is there between these two steel rods. It may be a 10 centimeter or 30 centimeter. And those racks will separate the water impurities or debris from water, from flowing water, whose permissible velocity is between 0.6 meter per second to 1.6 meter per second. So Between this velocity of water, the water is flow from this trash rack or intake structure from 0.6 meter per second to 1.6 meter per second. So this is the second component of hydroelectric power plant, that is the intake structure. Now we have another component, that is the third component. It is a penstock. So if you see this penstock, we are having a large diameter pipes are there. So these are the penstock. So penstock are like a large pipe which is lay with some slope. So we have slope is given from a dam structure which is at higher height to a turbine or powerhouse which is at lower height. So a slope is given which carries, now penstock carries water from intake structure or reservoir to the turbine. And generally penstock, they run with some pressure. So sudden closing or opening of penstock get causing the hammer effect. I have already told this hammer effect. So because of this hammer effect, these steel rods, steel pipes, it is designed in such a way that it will resist the hammer effect produced by this sudden closing or sudden opening of the penstock gate. So to overcome this pressure, a heavy wall is provided for the short length of surge tank. So we have this wall is there, this wall is there. So for short length, we have provided a heavy wall. So a heavy wall is provided for short length penstock, and surge tank is also provided in case of long length penstock. So the steel or reinforced concrete is used to making this penstock. If the length is very small, the separate penstock is used for each turbine. So if there are number of penstock, so every penstock we have a separate turbine. So if the length is very small, separate penstock is used for each turbine. Similarly, if length is big, the single large penstock is used at the end, and at the end it is separated into branches. So either for short length we use a number of penstock, or for large length we use one big diameter penstock, and after the ending we converted into a branches into a different penstock. So this is the function and we can say design consideration in case of penstock. Now next, fourth part, it is called as a surge chamber, or it is also called as a surge tank. So a surge tank or surge chamber is a cylindrical tank, like as shown in this figure. This is called as a surge tank or surge chamber. So a surge chamber or surge tank, it is a cylindrical tank in which it is open at top to control the pressure in the penstock. So at top, there is no closing is there. So it is open. So now this surge chamber or surge tank, it is connected to penstock as close as possible to the powerhouse. So it is connected between penstock and powerhouse. Now, whenever the powerhouse rejected the water load coming from penstock, the water level in surge tank is rises. So if the load in this powerhouse is less, in that condition, it rejects the water. That is, water flowing through the turbine, it rejects. And because of that, the water level in surge tank, it rises. And it controls the pressure in penstock. And in this way, we control the pressure in the penstock. And if we control the pressure in the penstock, the hammering effect goes on reducing. Similarly, when we required a huge demand of water or huge demand is there, that is huge demand of electricity is there. So in this case, the surge tank accelerate the water flow into the powerhouse. So in powerhouse, we have turbine and generator. And then water level of this surge tank, it gets reduces when there is a demand. And when there is demand is low, the water level inside this surge tank, it get rises. So this is the fourth component of hydroelectric power plant, that is the surge chamber, or which is also called as surge tank. Now, next component of this hydroelectric power plant, it is the hydraulic turbine. So we have this one type of hydraulic turbine. It is shown in this picture. So a hydraulic turbine, it is a device which converts the hydraulic energy. Now hydraulic energy, it is nothing but the kinetic energy of water. So water energy or hydraulic energy into an mechanical energy. So mechanical energy is a rotational energy. So hydraulic turbine, it is a device which converts hydraulic energy into mechanical energy. And this turbine is connected to generator. So that converts mechanical energy into an electrical energy by coupling this shaft of turbine to the generator. Generally, hydraulic turbines are mainly two types of hydraulic turbine is there. One is impulse turbine and another is reaction turbine. So this impulse turbine is also called as velocity turbine. So Pelton wheel, it is an example of this impulse turbine, which is works on a principle of impulse momentum theorem. And another another type of turbine, it is the reaction turbine. That is called as a pressure turbine. This reaction turbine is also called as pressure turbine. And this impulse turbine is also called as velocity turbine. So this reaction turbine, the Kaplan turbine and Francis turbine, these are the example of this reaction turbine. So this is the important parts. So if you see in the this hydraulic turbine, we have a number of blades are there. So these are the blades of hydraulic turbines from which we can generate the pressure, and when the water pressurized water, or we can say a water strikes on that blades, it will rotate the rotor of the turbine. So the mechanism in this when water strikes on the circular bed or runner, it will produce the rotational energy, or we can say rotation of this turbine runner. And because the shaft is connected to this rotor, the shaft is get also rotated. So this is the function of hydraulic turbine. Now we have next part, that is the powerhouse. Now if you see in powerhouse, we have the electrical parts of this powerhouse, which consist of the generators, alternators, then transmission lines. So all these considered are under this powerhouse, and controlling of the load. So this is comes under the powerhouse. So we have powerhouse. It is a building which provides to protect hydraulic element as well as electrical equipment. So hydraulic element, it is like turbine main, and electrical equipment like it may be have a generator and control room. So a powerhouse, it is a building which provides to protect hydraulic and electrical equipment, which is protect two types of equipment. One is hydraulic equipment, that is hydraulic turbine mainly, and we have electrical equipment like generator. So generally the whole equipment is supported by a foundation or substructure that is laid for powerhouse. So in case of reaction turbine, some machine elements like draft tube, then scroll casing are fixed with this foundation while laying of this foundation. So foundation is laid with a big dimension. So when it comes to superstructure, generator are provided on ground floor, which in which there is vertical turbine are provided. Now besides the generator, horizontal turbine is also provided, and we have another control room is there where it's provided on first floor, or it is also called as mezzanine floor. So generator is at ground floor and control room is at first floor. So this is about the powerhouse. It is a building like structure where it protects the hydraulic element, hydraulic equipment as well as electrical equipment. So this is the sixth part of this hydroelectric power plant. Now next we have draft tube. So a draft tube is generally used when we use the reaction turbine. When we use the impulse turbine, we does not use this draft tube component, but a draft tube component is used when we use a reaction turbine, like Kaplan turbine is there or Francis turbine is there. So we use this draft tube. So a draft tube is a necessary component which connects the turbine outlet to the tail race. So one end of the this draft tube is connected to turbine and another end is connected to tail race. So this large end is connected to tail race, small end is connected to turbine. So draft tube contains gradually increasing diameter. So if you see from turbine end to tail race end, so it is gradually increases. The diameter of this tube is gradually increasing, and we passes this to the tail race part. So the draft tube contains gradually increasing diameter so that water discharges it into a tail race with safe velocity. And at end of this draft tube, outlet gates are provided, which can be closed for a repair or maintenance work. Okay, so you have outlet gate will be there, so that will close the flow from this draft tube. So we can use this closed this draft tube during the repair and maintenance work. So this is the seventh part of this hydroelectric power plant. Now we have last part of this hydroelectric power plant, that is tail race. So next part is tail race. So tail race is a last component of this hydroelectric power plant, which is known as tail race. So if you see this tail race is the flow of water from turbine to the stream, or we can say flow of turbine to the river. That flow of turbine from turbine, and it is then passed to the river to a main stream. So that is called as a tail race. So tail race is a flow of water from turbine to the stream. Now this tail race is good if powerhouse is located near to stream and we can say river. If powerhouse is located near to river or stream, this tail race is good. But if it is located away from this stream, then we have to build a structure or channel for carrying this water, that is outlet water from turbine, into a mainstream. Otherwise, the water flow may damage the plant in many ways, like lowering the turbine efficiency. Then we have cavitation problem. Then we have damage to the turbine blades. So these are the disadvantages. So we have to build a channel if the powerhouse and tail race, they are located far away from each other. But generally, the tail race and powerhouse is located near to stream, so that it directly goes, the water from turbine outlet is directly goes to the tail race to a draft tube or tubes. So these are the components of hydroelectric power plant. So we have seen the different components of hydroelectric power plant as well as the function of each component. Now, the next point, it is the advantages. So first advantages is uh, in hydroelectric power plant, no fuel is required because we store the water in a dam, and from that water storing, we get a potential energy. We convert that potential energy to kinetic energy and then mechanical and then electrical for power generation. So we does not require any fuel like coal, oil or gas, anything. Second, it is a neat and clean source of energy because water is a clean source of energy. So we use this water for generation of power. Then third advantages is a very small running charges is required because water is available for free of cost. So for running of this power plant, we require very small amount or small cost. Similarly, again, less maintenance is required of this hydroelectric power plant because we have very less limited number of parts. As like in thermal power plant, we have number of parts, number of elements are there, temperature will be there. So because of that, maintenance will be high. But comparatively, thermal power plant, the hydroelectric power plant has less maintenance cost, and the life is also a longer of that component. Next advantages is because of using this hydroelectric power plant, it serves the other purposes like irrigation, or we supply water to industries also. So this is the another advantages of this hydroelectric power plant. And we have only two disadvantages of this hydroelectric power plant. So we require a very high capital cost for the construction of dam in a river. That is the main cost, that is we require initial cost more to construct a dam. And second one is we require high cost for transmission. So transmit the electricity from, because hydroelectric power plant generally they are located in hilly areas, and from that the customers are away from that hilly areas. So we have to use a transmission line from the hydroelectric power plant location to the distributed location, that is the substation or power stations. So these are the some disadvantages of this hydroelectric power plant. So in this way, we have completed this hydroelectric power plant. In that, we have seen how the hydroelectric power plant working principle is there, what are the different parts of this hydroelectric power plant, function of each part, and lastly we have seen the advantages and disadvantages of uh, hydroelectric power plant. So this is all about the hydroelectric power plant. So thank you very much.